Welcome back. Today we're going to be talking about solving two-step equations. This is day number 2, part 2, which is basically our focus on fractions. In the previous lesson we worked on decimals, and this time it is fractions. Our content objective is students will be able to solve two-step equations with rational numbers and check their solutions. Just a quick recap, rational numbers do include fractions and decimals. Language objective is students will be able to state the mathematical properties used when solving equations. And why am I learning this? Well, it's important for real-life problems like helping you decide how much pet food to purchase. So, as we're solving these two-step equations, there's a couple rules that we need to keep in mind when we're transforming these equations to figure out what the variable actually equals. Number 1 is to remember our goal is to make sure we always work to get the variable to one side of the equation by itself. Basically, we're trying to get the variable isolated. 2, whatever you do to one side, you got to remember to do it onto the other side. And then 3, to undo an operation, you're going to perform its inverse, aka the opposite operation, to both sides of the equation. So addition and subtraction are inverses, and multiplication and division are inverses. And last but not least, well, not last but not least, but number 4, always show all of your steps. And last but not least, this one, it is the easiest to undo addition or subtraction first. Okay, so with that said, let's take a look at our first equation. So here we have negative 3/8x plus 2 equals 3/2. So the very first thing I'm going to do is I'm going to try my best to draw a straight line. Is I'm going to separate the equation into two parts, a left side and a right side. Why am I doing that? Because by doing that, I notice my focus should be on the left side because that's where my variable is. And unfortunately, it's not isolated yet, so I need to work at getting that to happen. So, just like the previous slide, it did say it is the easiest to undo addition or subtraction first. And that would be right here, which is the plus 2. This is what we call our constant. So, we're going to go ahead and do the opposite of adding 2, which is to subtract 2 from both sides. These are additive inverses, so that does create a 0, so now that's gone. So left on this side is just a negative 3/8x equals, now here, I'm going to have to simplify that, so this can be some side work. We have 3/2 minus 2 over 1. So what I'm going to do now is get my common denominator. The 3 is going to stay the same, however, this has to be multiplied by 2. So 2 times 2 is 4. I'm going to add the opposite here. There are definitely more negatives, 1 to be exact, and 2 remains my denominator. So I have a negative 1/2 here. Now we're not quite finished yet. We still have our variable on this side that has not been isolated yet. So I need to get rid of the negative 3/8, which is our coefficient. And this, since it means negative 3/8 times x, the inverse would be to divide both sides by negative 3/8. The negatives cancels out, the 3/8 cancels out, leaving me with just x equals. Here, you can think of it as the negatives cancel each other out. Now here, this is where a lot of students make mistakes. If you were to read this out loud, you would say 1/2 divided by 3/8, which looks like this, 1/2 divided by 3/8. But this is a very common mistake. Instead of doing that, a lot of students do this. So again, this is wrong, but this is what some students do. They put 3/8 divided by 1/2. So in other words, they flip-flop the order. Please do not do that. That is incorrect. So if you question whether or not the order is correct, simply read it in order. 1/2 divided by 3/8. 1/2 divided by 3/8. Perfect. Now I'm going to go ahead and multiply by the reciprocal. So we're going to go ahead and take the reciprocal of that, which is 8/3. 8 and 2 have a 2 in common, so this becomes a 4, this becomes a 1, leaving me with just 4/3. Okay, so here is my answer. However, I'm not done yet because I still need to check my work and make sure that this answer is what's going to create a true statement for my equation here. So, starting with my equation, negative 3/8, instead of x, putting a set of parentheses, plus 2, checking to see if this does equal 3/2. So I'm going to go ahead and plug in my 4/3. Since it's this is basically multiplication, or you can think of it as distributing, I'm going to go ahead and cross reduce. First, before I do that, let's take care of the sign before I get lost in all the work. A negative times a positive is a negative. 4 and 8 have a 4 in common, so 4 divided by 4 is 1. 8 divided by 4 is 2. And then the 3's here will cancel each other out, turning into 1, which is going to leave me with negative 1/2 plus 2 equals 3/2. Now we're going to simplify this side right here. We're going to get common denominators. And in order to do that, I am going to first go ahead and keep a common denominator of 2. Make sure that stays negative. It's going to stay the same. And then here we're going to multiply this by 2. So my new numerator is a 4. Is this true? I'm running out of space, but I will write it right here. Between negative 1 and positive 4, there are more positives. 3 to be exact. This 3/2 equals 3/2. The answer is yes, so I'm very confident that my answer is indeed 4/3. Okay, now let's go ahead and look at number 2. So same idea. I personally like to first separate the two sides. That way I know where to focus. Since the variable is on the right side, that's where my focus is going to be. And just like the other slide, we do want to undo addition or subtraction first, which would mean I'm going to get rid of my constant here, which is negative 3/2. So the opposite of negative 3/2 is a positive 3/2. So here, I'm going to go ahead and add it to both sides to keep them balanced. This is going to become a 0 because those are additive inverses, leaving me with just 5/2 d equals, now here I'm going to do that off to the side, negative 1/2 plus 3/2. 2 is going to be my denominator. Here, since they're already the same, I'm just going to go ahead and say there's more positives. 2 to be exact. 2 divided by 2 is just 1. Now here, I just am still focusing on the right-hand side. I need to go ahead and get rid of this coefficient of 5/2. Since it does mean 5/2 times d, I'm going to do the inverse, which is to divide both sides by 5/2. So now, these are going to cross cancel, which is just a 1. So now I'm left with d equals, now to simplify this, this is 1 divided by 5/2. I'm going to go ahead and turn this into a fraction. Now that I've done that, I can go ahead and multiply by the reciprocal, which is going to give me a positive 2/5. But as always, before I claim that that is indeed my final answer, I should probably check my work. So I'm going to go ahead and copy the equation exactly the way that it is. Negative 1/2 equals negative 3/2 plus 5/2 times d. d is going to be set of parentheses, which is going to be filled in with 2/5. So here we have negative 1/2. Notice I just bring it down because it's already simplified. I'm going to bring down negative 3/2. Here, the 2's cross cancel, and so do the 5's, leaving me with just plus 1. So we have negative 1/2, half equals negative 3/2 over 2 plus 1 over 1. I'm going to keep this the same. I'm going to go ahead and get common denominators. This is going to stay negative 3, but this one's going to be altered by a 2. So if I simplify that, I would be left with negative 1/2 equals negative 1/2. So I'm very confident that my answer is indeed 2/5. Okay, so last but not least, number 3, we have negative 1/10 equals 2h minus 3 and 24/100. Okay, so notice here we have fractions and we have decimals. So before we do anything, we're going to look and see, is there one method that's better than another? You're going to hear me typically say if you have a choice, you're definitely going to want to turn decimals to fractions because you're more accurate that way. But if the opportunity presents itself where it's obviously easier to turn things into decimals, then do so. Now, you don't want to turn things into decimals when? when you have a repeating decimal and things like that. But generally speaking, if it works out nicely, that's okay if you choose to turn things into decimals. But preferably, if you had a choice, fractions would be best. But number 3 is a great example where it would be easier to just keep everything in decimals, and I'll just tell you why in a second. Here, you're going to notice this is a 2, this is 3.24. Both of those are basically could be expressed as a decimal. And then we have this, -1 and 1/10. This can easily be converted into a decimal. It's just basically -1 and 1/10. So this is a great example of keeping it as a decimal is totally fine. Now, why would I prefer that over turning things into a fraction? Because this right here will not look pretty. 3 and 24/100ths looks like this, which then can be reduced by 4, which is going to give you 6/25. So this is going to become 75 plus 6 is, just do some side work, 75 plus 6 is going to be 81/25. Now, is it completely wrong to do this? Absolutely not, but either or will work. So I did keep it as a decimal because this number here was easily converted into a decimal. I'm going to go ahead and add 3 and 24/100ths to both sides. Definitely going to say that there are more positives. How many more positives are there? Well, let's see. Notice I'm lining up my decimals. These were positive, these were negatives. It's going to be a 4, a 1, and a 2. So we have +2 and 14/100ths equals 2h. Okay, so my variable is still not isolated yet, so this means 2 times h. So I'm going to have to do the inverse. Instead of multiplying by 2, I'm going to divide by 2. That's going to cross cancel, leaving me with h equals. Now I'm going to go ahead and divide, doing some side work. We have our 2 and 14/100ths divided by 2. 2 goes into 2 one time. Bring down the 1. 2 goes into 1 0 times, which is a 0. Bring down the 4. 2 goes into 14 7 times. Now, real quick, a lot of students where they tend to mess up is right here. When they brought down the 1, they would see that it can't go into 1, and they would automatically bring down a 4 without even putting a 0 as a placeholder there. So in other words, some students may have answered like this. Now, hopefully, if you checked your work, you plug that in for h, you're going to find that it doesn't work, and I hope that you catch that. But otherwise, just be very careful. So here we got h equals 1 and 7/100ths. Now, before I claim that that's my final answer, we always need to make sure we check our work. So we have -1 and 1/10 equals 2 times parentheses minus 3 and 24/100ths. Here is where I can go ahead and plug in my answer of 1 and 7/100ths. So we have -1 and 1/10 equals, this if you multiply it out is going to be 2 and 14/100ths minus 3 and 24/100ths. So here this is going to be -1 and 1/10 equals, here there's definitely more negatives. How many more negatives than positives? Well, there's 3 and 24/100ths negatives, and there's 2 and 14/100ths positives, and that's going to leave me with -1 and 1/10. These look different, yes, but however, these are equivalents. You can write this as this or this as this, same thing. So guess what? For those reasons, I'm pretty confident that my answer for h is indeed 1 and 7/100ths. Okay, well, thank you so much for tuning in. And as always, until next time, bye!